Okay. Are you ready?
Yeah.
Okay. All right. We're recording. Just check. Okay. Okay, good afternoon. It's my pleasure to introduce our speaker, Mike Stewart, 顾一华. He just joined our institute this semester, so this talk is a great way for you to know more about his research and also know more about him. And it's really nice to have other professors and scholars here. I think I see Tony Zheng from Zhengzhi University and Chen Guizhen from Academia Sinica and Zhang Lihong, also from our school. And Jonathan, Karen, yeah, from our institute. Okay, I'll say a bit about Mike, and then I will let Mike introduce himself in more detail. Mike got his PhD from Institute for the History and Philosophy of Science and Technology at University of Toronto. Then he has worked at many different places like University of Pittsburgh, London School of Economics, University of Tübingen, University of Geneva. These are like really beautiful places. And now National Yangming Jiao Tong University. And his research interests include epistemology of science, and in particular, the role of imagination in scientific practice. In addition to that, he has also published several papers on AI ethics and also in meta-philosophy. And Mike has many talents. He speaks and is learning seven languages, and he's also cellist. He plays the cello. And I think there's actually a lot more, but I'll leave it to you guys to explore. So I'll now hand over to Mike.
Thank you so much, Ington. That's so nice. I don't know if I would say I play the cello in as much as I make a lot of loud noises with the cello so far, but hopefully that'll get better. Okay, so I'll just jump right into this. I'm sure everybody is excited to hear more about space because that's why I picked this topic, of course, not for the philosophical merit or anything. I should say right off the bat that this is collaborative work with Dr. Hannah Sargent. So she's a planetary scientist at the University of Central Florida. And before I get into any of the real details, I wanted to say a little bit about the sort of the abstract relationship between philosophy of science and science, and how I see my work figuring into this. So there's a couple of different ways philosophy of science and science can relate to one another. If we think about this, the top arrow here, we can think about philosophers kind of looking at the way the science is done. So science does a bunch of stuff, and that informs philosophers in some sense about some philosophical topics that they find interesting. And then on the other hand, you can have philosophers making some findings or making up some theories or accounts, which then helps the scientists do their own work. So for example, Einstein famously hit a couple of theoretical brick walls and drew inspiration from the work of Immanuel Kant and some others. And of course, modern biologists have profited quite a bit from the definitional and conceptual work that philosophers have done on concepts like stem cells or the microbiome. Obviously, there's a lot of similar kind of overlap with consciousness studies and so on. I think in the end, you want both directions. You want a virtuous, complete circle where the philosophers look at the practice of science, they learn something about how science is done, then they come up with some account, which then helps the scientists do their thing. In the case of imagination, which is what I'm interested in today, what we want is to learn something about how the imagination, for example, produces new knowledge or new understanding. And then we analyze what we find, produce an account, and then hopefully that will help scientists understand their own imaginations better so that they can use imagination and teach imagination to the next generation of scientists more effectively. So this talk is mostly going to be about the first step, the top step, learning about how imagination works to provide new knowledge and understanding in science by looking at the practice of science. But obviously, I'm also very interested in the bottom arrow, and I'm very happy to talk to people about that in the Q&A if anybody's interested. So in the past, I've looked at imagination in biology, physics, chemistry, math, and climate science. And you can read elsewhere, or we could discuss some of that stuff. Today, I'm going to focus on space science, which I think is important for a number of reasons. For one thing, space captures everybody's imagination. It's one of those things that's just naturally tied to imagination, it seems. Second, more specifically, the imagination is important for space scientists themselves. A kind of obvious point is that most of them, if you ask them, grew up reading science fiction, or they later on write science fiction themselves. But about the practice of space science, space is unknown and constantly surprising us. I think it's really hard to do space science in any kind of routine way, because you're always faced with completely new problem situations. You don't know what, for example, exactly what a new planet that you're exploring is going to be like. So there's all kinds of really exciting and interesting challenges. And you also have to be thinking 5 to 10 years in the future all the time. You don't plan a mission and then carry it out tomorrow, see what happens. You have to plan, 5 or 10 years in advance. And when you do that, you have to be thinking 5 or 10 years in advance in terms of what technological capacity is going to be at that time and so on. So I think it naturally requires a lot of imagination. I'm going to be talking about epistemology, but there's also lots of interesting ethical questions that I just want to raise very quickly about the use of imagination in and around space science. So for example, in 2016, only 14% of SpaceX employees were women. And there has historically been an extreme amount of underrepresentation of women and other groups in space science. And that has all kinds of effects on the kind of imagination you find in science. And also it tells us something about the kind of imagination people have in space science, perhaps. So just for example, on the top right, you have a graph charting the number of women versus the number of dogs who have gone to space. And that's pretty crazy. It's not like it's, 1 or 2 and then the women catch up. They're up to like in the low 40s or 50s of dogs before you get, any women in space. And basically, I just want to agree with Dr. Mae Jemison, an astronaut, that to a large extent what's happened is that the people in charge have had very limited imaginations when it comes to what an astronaut looks like, sounds like, and acts like. But one of the beautiful things about space is that it's largely a blank canvas on which we can paint our images of the future, and we can fight for certain images over others. I don't think it's inherently masculine or anything like that. I mean, the field is changing rapidly, and I think we can expect better from it. Still, in this talk, I want to focus on epistemic uses of imagination. It's not to say that the ethical stuff that I just mentioned isn't epistemic. It's also epistemic. If you limit the number of cognitive perspectives on a topic, you're going to damage it, epistemologically speaking. But I want to talk about kind of extremely straightforward epistemic uses of imagination in space science, like how to solve particular epistemic or practical technical problems in space science. Of course, these might also have ethical upshots. For example, if we solve a bunch of problems, we make a bunch of epistemic progress or practical progress in space science, that enables us to colonize, for example, some other planets. And those other planets, it turns out, let's say, have some kind of native microbial life. There could be ethical upshots there about whether or not we want to colonize the planet and so on. So there's, of course, lots of interesting ties between epistemology and ethics. But okay, we could do epistemology of lots of things. Why do epistemology of space science? Well, for one thing, it's new. Philosophers of science have only started talking about space science in the last few years. There's a couple of reasons why that might be. One reason is that engineering plays a really, definitely because it's cool. And I think because engineering plays such an important and crucial fundamental part of space science, and philosophers for a long time wanted to focus on more theoretical kinds of science, like theoretical physics or theoretical, let's say, evolutionary biology. I think turning to more engineering heavy science is a really interesting thing to do. Also, one of the reasons why space science is different and maybe special is that it's not just interdisciplinary, it's like radically interdisciplinary. So it includes, in a single lab, you'll have geologists, chemists, biologists, or astrobiologists, physicists or astrophysicists, astronomers, cosmologists, and engineers, and a whole team of lab techs. So that makes it, I think, kind of a more extreme version of other interdisciplinary sciences. One last thing I want to mention is that the aim of science, well, there's a big philosophical discussion about what the aim of science is. Maybe it's trying to get new knowledge or new justified true beliefs or justified beliefs or accurate beliefs or new understanding. That's also true for space science, but space science, in addition, wants to explore the universe. And exploration is not the usual aim that you find in most sciences. Most sciences, they say, we want to find out the truth about what, how quarks work or something. But here we want to do that. In addition, we want to explore. I think that's interesting. So all of that is to say that the purpose of this talk is not just to make the epistemological point I want to make about the role of imagination, but also kind of just to get people excited about the epistemology of space science in general, philosophy of space science, and so on. Okay, so more concretely, the plan for today is to introduce some of the methodology that I use to get some of the data that you'll be seeing, introduce scientific imagination, present a brief case study, apply a specific epistemological distinction that epistemologists have made and been arguing about for a very long time, but which you don't actually see very often applied in philosophy of science, between internalism and externalism. And then we'll just draw some conclusions. So what I've been doing is looking at different laboratories using ethnographic methods. So usually what I do is I'll go into a lab for a couple of months when it wasn't coronavirus time and do interviews with the participants, the members of the lab, including the PIs, and also observe their lab meetings. And then I'll record everything and code everything using typical social science coding methods. And I've done this now in 8 labs starting in 2015. So 2 climate science labs, 2 systems biology labs, genetics lab, mathematics lab, physics lab, space science lab. And just to give you a brief sample of some of the things scientists say. So they say, I cannot think of a scientific field where you could work without imagination. That's in climate science. In space science, a PhD student says, imagination is hugely important. There's this absolute requirement to be imaginative. In systems biology, a PI says, imagination is extremely important to me. Through imagination, you don't just develop new techniques. You also frequently more directly look at whatever it is you're looking at. And then in physics, the PI at CERN says the only moment in which you do not have to imagine is when you have to assemble something with instructions. And even then, and he goes on, anytime you have to make some kind of measurement, you should have a lot of imagination, since imagination creates the environment for the measurement. Also, when you have your data and you have to understand your data or extract from your data something that has not been seen before, you need imagination. So that's just a brief sample from very different fields of science. Climate science, the Large Hadron Collider, biology, space science, and so on. So scientists overall appreciate the importance of imagination in their work. In previous work, I've tried to show that whatever you think scientific progress is, imagination contributes it mostly by helping us to solve problems. And it helps scientists solve problems in a number of ways. So you may, need a new hypothesis to explain some empirical result. So imagination can help there. Imagination can help search a problem space. If you say you've already performed a test, you have the empirical results, you've double checked them, but you don't really know exactly how to interpret the data or how to solve a technical problem, you can consider lots of different possibilities. It can help you design experiments and so on. So these are all ways that imagination can contribute to problem solving. And that's still a bit vague. So first I want to say a bit more about what I mean by imagination when I talk about it, and then we'll go into the case study where we can see very specifically how imagination is used to solve problems in a particular case. So the first thing we should do when we try to think about epistemology of imagination is to think about what kind of thing we want to think of imagination as being. Do you want to think of imagination as a character trait of an agent, or a faculty sort of agents' minds, or an ability, or an action, or a mental state? You can find people talking about imagination in all these different ways. in previous work, I've argued that just basically for reasons of philosophical convenience, it makes the most sense to talk about imagination as an act, or if you like, as a process. So when the process is done, when the process is carried out deliberatively, consciously, you can say it's an act. And when it's done kind of unconsciously or automatically, then you can say it's, if you like, it's just a process, if you want to make that distinction between actions and non-actions. But I'll talk about it as if it's an action. So what kind of action is the action of imagination? Well, the kind of act we're interested in, generally speaking, is when scientists explore some kind of problem space using, let's say, at least one mental representation, and at least part of that representation or some of the representations is different in some noted ways from what the scientist believes to be true or accurate about the target system. And the imagining should have an epistemic purpose. That, I think, would satisfy a lot of people who work on imagination, but we can be more specific and we can kind of focus in on a particular kind of imagination. So this definition is from Benjamin Sheridos and Bill Bechtel, and it's not meant to say this is what imagination is. It's supposed to say here's one kind of imagination that they want to focus on. And I think it's good for at least the purposes of my talk today. So for them, some cognitive act counts as an active imagination if it's imagistic. In other words, they want to focus on perception-like imaginings. If you think about a purple elephant on a unicycle on top of the Eiffel Tower juggling or something, you're kind of, let's suppose you have a mental image, unless you have aphantasia, which we can get into later. That's a kind of sensory imagination that's different from a kind of pure abstract thought like imagination. Sometimes people call that propositional imagination. I'm not saying that that's not a kind of imagination, and Sheridos and Bechtel are not saying that that's not a kind of imagination, just that they want to focus on the perception-like kind. It's also going to be fictive in the sense that it contains aspects that aren't presumed to be actual. So even if everything that you represent in your mind in a visual imagining or a sensory imagining is actual, that's fine. It's just not presumed to be actual in the course of the imagining. It's supposed to be creative in the sense that it tries to envision something new. Students of mine in the creativity class will know that that's not the only way to think of something as being creative. That's the way that they want to say that imagination that they're interested in is creative. And it's got some free variability. So it's you can think of it as more free than some other mental acts. It's, for example, as a mental state, it's more free than belief. If you can't choose to believe something, or at least people argue that you can't. Imagination, you can kind of choose to imagine more or less whatever you want. There are, of course, limits, but it's pretty free. So let's get into the case study. So this is the prospect package. It stands for the package for resource observation and in situ prospecting for exploration, commercial exploitation, and transportation. That's a kind of ugly acronym, but it gets the job done because it ends up spelling the word prospect, which is very important for them. They think it's kind of nice. It reflects this old-timey idea about prospecting kind of in the Wild West, looking for resources that might be useful or valuable. So here's what the Luna 27 mission is going to look like. And what we're interested in are, this part here is a drill. This part here collects the samples from the drill. You see that there's this kind of row of little small containers. So there's 24 of them. Each one of them contains a sample, will contain a sample. They bring the samples basically to the PROSPA lab, and that's actually mostly what we're going to be talking about is the PROSPA lab. And that's where the work gets done. This is going to be flown in the next few years to the southern lunar pole. I had a video, actually, I don't think I have time. I'm talking too slowly, I guess. Maybe I'll just show, the sound probably won't work. Does the sound work? No? Okay, that's fine. It's nice to see videos of things rather than just images. So this is what the drill looks like. It drills down to 1 meter below the surface. These are the places where the samples are held. Yeah, that's probably fine. That's Hannah explaining the project, but since the sound doesn't work, we don't really need that. Okay, so the basic idea at first was to have the Prospa lab basically check to see if there was water. So it would drill down, it would get these samples, it would heat the samples, and then it would take the gas that was produced by heating the samples and run it through a mass spectrometer to see if there was water. And the idea is on the south and north poles of the moon, there's probably going to be some water. And they think that's kind of important and interesting because likely on the way to Mars and on the way to further human exploration of the solar system, you're going to need water. So if there's water on the moon, that's a good thing. What we're going to talk about is an extension of that idea. That was the original idea, but it's since been developed. So what if instead of finding water, you could make water on the moon? If you could take rocks and, from the rocks, get water. And that's an extension of what just happened actually just a few weeks ago. Perseverance has its own little drill and its own little lab there that produced oxygen from moon rocks. Basically, there are certain kinds of rocks that have oxygen in them. If you heat them up to a certain temperature, they'll release the oxygen. What Prospa is going to do is combine the oxygen with hydrogen to kind of prove that in principle you can make water in space from rocks, and then you can scale it up to make lots and lots of water from moon rocks, which is surprising and also amazing, because if you can do that, obviously you have water, which is extremely important for hydroponics and agriculture. If you have little moon bases, also for humans, of course, we need that too. But also you can separate water back into the oxygen and hydrogen and make rocket fuel. So we're gonna need that. Of course, there are obstacles like there are with anything. So you heat the lunar regolith, the lunar basically dirt. It contains ilmenite or other sorts of rocks that also contain oxygen. If you heat it to about 1,000 degrees, that produces oxygen. You add hydrogen, you get water. But you need a way to extract the water to make sure that you can test the water to make sure that it is water, and so on, how much water you have. The usual way you would do that isn't possible for Prospa. Prospa, it has to be light, it has to be small. So they came up with the idea of using what's called a cold finger, which is a small piece of chilled pipe, which will attract the water vapor to condense on it. And then you can kind of get the cold finger separate, and then you can heat up the cold finger and check for a rise in pressure. And the rise in pressure will tell you about the presence of water, how much water you have. So it's exactly like boiling a kettle. Of course, the pressure inside of a kettle increases when you're boiling the water. This is what Prospa looks like at the moment. So obviously as a mechanism sketch. So you've got the kind of intake system. You've got 25 different little tiny ovens for the little tiny, no, they're not that tiny, but they're pretty small ovens for each of the samples. So you heat up the samples, and then you have all of these different basically gates that allow different things in. So you can bring in your supply of hydrogen through the gates to mix with the oxygen. Here are the cold fingers. The cold fingers attract the water vapor through the pipes. Then you can seal the cold fingers, heat them up, check for pressure, and you can run everything through the spectrometer, the mass spectrometer. This is what an early version looked like. It's not nearly as pretty as the pictures I was showing before. Those were kind of the final product. This is what it looked like as they're beginning to test it. So that the mass spec is very big. You've got the cold finger, which is kind of just wrapped in a ball of tin foil. The heating elements are just sort of just out in the open. Everything is really big, which is of course significant because when you try to scale it down later on, you have to think pretty hard about how well that's all going to work. But that's the idea sort of what it looks like in the lab. So there was two problems I'm going to talk about briefly that imagination is involved in solving. So one of them is that when you have the cold finger traps a bunch of water vapor, and you heat the cold finger, and that produces a rise in pressure. They had earlier calculations about what the pressure should be given the amount of a lunar regolith. So they were actually doing this on samples from lunar soil that were gathered by the Apollo missions. And so given their calculations, there was a certain rise in pressure they expected, but the rise in pressure wasn't as high as they thought. So they checked for gas leaks. They didn't find any. They checked for pressure sensor malfunctions and they didn't find any. And they didn't know what to do. Why wasn't the rise in pressure high enough? Second problem was that you have this rise in pressure, which is good, but it's not as high as you expect it to be, which is a problem. But then after that, secondly, it suddenly drops after it rises. So it rises and then it drops, and they had no idea why that would happen. Again, maybe there's some kind of gas leak, or maybe there's some kind of pressure sensor problem again. They check for all that, and they don't find anything. And those are just two examples. Over and over again, this is what happens. There's a series of problems, and you just kind of go through each one. It's problem solving until you get to the finish line. Each problem is a combination of pure and applied, or if you want theoretical, technical, or practical issues. You're not sure in any case whether the answer to a problem is going to be because there's a technical fault or some kind of theoretical mistake that you've made, or discovery that's around the corner. Each of these problems, according to the scientists, requires imagination to solve. Many of them were solved only through collaborative acts of imagination. So they imagined together over a whiteboard. Sometimes they would, the way that a philosopher would put it is they distribute their imagination across different people and machines and material instruments. So they're also using computer simulations and computer models, back of the envelope calculations and so on. They all claim that they're extremely visual imaginers. So I explained to them what aphantasia is. Aphantasia is this condition where you don't have or don't experience sensory imagination. They were completely mind blown by that possibility. They had never heard of it. It wasn't relevant to any of them. One thing it seems like we can confirm an earlier finding is that it seems to be true, as I found in a different lab, that scientists only start imagining when they've tried everything else and nothing else works. All of the usual methods are done first. You check with all the experts you possibly have access to, you check all the obvious things, you redo all the calculations, and so on and so on. So that's, of course, what they did in every case. But in the cases that I mentioned, and in a bunch of other cases, they don't know what else to do. So then they start imagining together. And typically this involves visualizing the experiment on a micro scale and imagining what could be going on inside the instrument. So the solution to the first problem was that the rise in pressure wasn't as high as they expected it to be, was that they realized by imagining what was going on in the experiment, as you imagine the kind of water molecules like little balls and so on, like as they're portrayed in textbooks, you imagine them going through and you imagine what's happening. And when they imagined carefully enough, they realized that the problem was that they halt the experiment at exactly 4 hours, because 4 hours is all the energy you can get when you're on the moon. You can only do an experiment for that long. So given the sort of energy requirements and the energy output that the lander has. And so they halted at 4 hours. And at the end of the 4 hours, they think that all of the material has been used up, all the hydrogen, all the oxygen, all the oxygen that you could get from that sample. But that's not true. The reaction continues inside the instrument, inside the oven. It's still producing oxygen. Hydrogen is still mixing with the oxygen and producing water, which is sticking on the regolith. It's because you close off the seal between the oven and the cold finger. The cold finger doesn't have all of the water that there is in the system. So pretty simple solution to that one. And the solution here is kind of understanding what's going on in the machine, being able to understand why the rise in pressure isn't as high as you expected it to be. The solution to the second problem was more difficult, but it was done in the same way. So the second problem, to remind you, was that the pressure from heating the cold finger went up and then dropped. And they were assuming that the water molecules would turn into vapor when you heat the cold finger, and that should produce a rise in pressure. If it's not producing a rise in pressure, if the pressure drops, it must be because the water molecules are no longer hitting the pressure sensor. Why would that be? And they thought, well, maybe the water molecules aren't staying as vapor. Maybe they turn into vapor when they're heated, but then they turn back into liquid. So maybe there's something else in the system that's acting like a cold finger, other than the cold finger that's allowing it to do that. Now, that shouldn't be possible. But it turns out if you talk to enough experts, the way that water works in a vacuum is very different from the way that water works other sorts of places. It's really hard to stop water from condensing on pipe walls. Now, the way they did it was they wrapped heating elements around all the pipes to make sure all the pipes were hot and only the cold finger was cold. But wrapping around the pipes wasn't enough. It wasn't consistently hot enough, so the water would condense in between where the heating coils were wrapped. That meant that they had to make the entire thing perfectly uniform, high temperature. So the only thing that was cold was the cold finger. And to do that, they had to completely change the entire system and build the whole system in its own oven, basically. And that meant you had to use new materials. They had to rethink which parts of the thing could be heated that high, which parts could not be heated that high, how you could redesign the entire instrument. So here's a brief summary of some of these problems. How do you get the water out without using recirculating gas pump? You can use the cold finger. How do you understand these pressure differences? You can think about water as being sticky, as not having completed the reactions. How do you fix the pressure differences? You have to heat the entire device. So that's some of the stuff that happened. Now, I think those uses of imagination were in some sense good, and we want to explain the sense in which it makes sense to say that they're good. One way is to use different meta-epistemological frameworks. So I've been doing this, but I didn't want to do it again this talk because Ingtong and Ira and some other people have already heard that talk. So I won't repeat any of the things there. But I'm happy to talk with people about it in the Q&A if we want. That's kind of a summary of it. We can ignore that. Today, I want to talk about internalism and externalism as possible resources that you can bring in from epistemology, mainstream epistemology, to help here. Now, the fundamental question that divides internalists and externalists is about the accessibility to the mind of the grounds for epistemic value. That's maybe not super clear yet, but it will be. The idea is that for an internalist, the grounds of the thing that, let's say, justifies your final belief has to be accessible to the person we're talking about. For an externalist, that's not necessarily true. That's what makes them externalists. But let's get into a bit more detail. So, of course, there's many different versions of externalism. The basic idea is that acts or mental states that have epistemic value should be defined in a way that's mind independent. So it doesn't really matter what I think I know, or I think I understand, or what I think I can do. What matters is what I actually understand, what I actually know, what I can actually do. And it's not me that decides what that is. It's in some sense externally the case. It can be appraised externally, what I actually know or what I can actually understand. So let me give two different cases that kind of makes this clear. So let's suppose I make a guess about where Daisy the dog is right now. And let's suppose that my guess is right. And let's suppose that I have no idea whether I'm right or wrong. I have no evidence that my guess is right. Still, I believe that I'm right for, by stipulation, literally no reason. But I stand by it. Despite the fact that everybody tells me, Mike, there's no such thing as telepathy or psychic connections or clairvoyance. There's no reason for you to be so confident, but still I am. Now, let's suppose there's two versions of this case. In one version, I'm right about where Daisy is, but it's a chance, just pure fluke. In the second case, I'm right because I actually do have a psychic connection with Daisy. I don't know that, and there's no way I could find out about it, but it is actually the case. Now, the externalist says we have to treat these two cases in completely different ways. In one case, the first case, where it's just a fluke, I am not justified in my belief. I'm not justified at all. But in the second case, no, don't tell me where Daisy is. I'm supposed to guess. In the second case, I do know I am justified because externally we can say that there is an actual connection between me and Daisy. The psychic connection does hold. The internalist says we should treat these cases as exactly the same. In both cases, I have this random guess. I'm way overconfident about it. I have no reason to believe it. So I'm equally non-justified in both cases, whether I have a psychic connection or not. And the externalist says, no, in the case where I had the connection, I am justified. In the case where I don't, I'm not. So that's kind of a one way to think about this distinction. So One way, more specifically, to think about externalism is to talk about reliabilism. If my beliefs and abilities were formed in a reliable way, then they have epistemic value. And otherwise, they weren't. So we can say that if you're an externalist, these acts of imagination I'm talking about are going to have epistemic value if they were produced in a reliable way. Now, so as I say, the imaginings are going to be good or bad depending on whether they're reliable. And I think there's some plausibility here. You might think that some people, and some philosophers have argued that some people have imaginations that are reliable. They reliably produce useful outputs. So Amy Kine talks about Temple Grandin and Nikola Tesla and some other people. She says that these are people with remarkable imaginations that pretty reliably get you to the truth or get you to a justified belief or something like that. And I've argued before that there's a kind of imagination which is unconscious, which can be trained by relevant previous experiences. So if you're, let's say, a firefighter and you're in you're fighting a fire and you see a door and you think about opening it and you immediately have an imagining that if you open the door, there's going to be a backdraft. A lot of people are going to be in danger. So you don't open the door. That imagining was trained by your relevant experience as a firefighter, so it's reliable. So you might think reliabilism, externalism works pretty well. I think externalism also has in its favor the fact that it captures quite a lot of scientific practice. And some philosophers think scientific practice actually proves externalism, reliabilism correct. If you look at the way that scientists talk about experiments or computer simulations or even cases of induction that are successful, it looks like scientists are externalists quite a bit. So if you say, I've performed this experiment, I think it justifies the following conclusion, the scientists don't say, but what beliefs and evidence do you have mental access to that justifies that conclusion? No, they'll just say, let me look at the experiment. If it was a reliable experiment that was using reliable measurement devices and so on, then it's justified. That's it. What matters is the reliability of the process. If you have a computer simulation and some scientist doubts it, it's probably because they don't think that the computer simulation is reliable in that context. But I don't think actually externalism works very well for scientific imagination. Sure. Yeah, Karen, do you have a question?
Oh, okay. So what if the case, because when for scientists to judge whether their experiments are reliable enough, sometimes they involve their, you have to bring in some, I won't say it's internal, but there are some other factors. Okay, maybe I have to say internal, but maybe some more mental things. So what I want to say is that push this. So you think it support externalism because it would rely on the judgment of whether experiments running reliably, but but this judgment may be formed by some factors that at least partly involve whatever you're going to call internal or suppose that's internal. Then how this? So I'm just wondering what if this happened without that affects your point here?
Yeah, no, that's really important. So I think what I said or what I meant to say was that some philosophers think that looking at scientific practice supports externalism, but not all philosophers think that. So there was a paper actually from this year that says, actually, if you look really closely, you can find internalist perspectives on quite a lot of the things that philosophers think usually are externally appraised. And internalists do generally have this argument that externalism eventually has to rely on something that's internalist, because all we really have access to are things like previous perceptions and experiences and that kind of evidence. Whereas, of course, externalists won't accept this at all. They'll say, who cares what people have access to? The question isn't about access. The question is about, objective justification or something like that. So the debate goes on, and I wouldn't say that externalism is proven right or is the best thing to capture how scientists talk about all of these things in general. So thanks for pointing that out and having us clarify that. Yeah, Karen?
Oh, I want to say thank you. That's all.
Okay, great. So I think if you look at the way scientists talk about imagination, they don't talk in a reliable way. So of course, a reliabilist way. So this isn't a knockdown argument against externalism or anything like that. But when scientists imagine a solution to a problem and share it with other people, they don't stop and say, like, to evaluate this idea, let's consider whether the conscious and subconscious processes of imagination in the imaginer were reliable. They don't do that. And they should if they were externalists. If somebody says, here's an idea that somebody imagined that could solve this problem, they don't say, wait, hold on, I need to know who it was because I need to know whether I should trust it because I need to know if it was somebody who had a reliable imagination or somebody who doesn't have a reliable imagination. They don't do that. What they do seem to do is they kind of just already know, or they quickly find out whether an idea that somebody else imagined is a good solution. And they do that using their own imaginations. They kind of investigate it on their own in their imagination to decide if the idea is a good one or not. How do they do that? I think what's going on is they're somehow checking to see if the imagined idea is reasonable or rational, or if it makes sense, kind of just in general. Does the idea make sense given what they know? And that kind of sounds a bit internalist. So are they internalists? So let's look at internalism. So there's many different versions of internalism. The basic idea is that acts or mental states that have epistemic value should be defined in a way that's mind dependent. And if you do that, that makes the definition of epistemic value somewhat more useful for humans, because we can always check if we are doing things kind of epistemically right. So believing my guess about where Daisy is irrational for the internalist, as I said, in both cases, because I have no reason to believe that I'm right. It's about what reasons I have. To be rational, I need access to whatever grounds the epistemic value of my beliefs or abilities. And like I said, that could be perceptions or arguments or things like that. So one way that internalists go about arguing for internalism is by relying on something that you might think of as being called Deontic Epistemology. Let me say a bit about what that is. So Deontic Epistemology is kind of like deontology in ethics. The idea is that right actions are defined kind of irrelevant of the consequences. The rational thing to do is to follow or obey or respect some epistemic duties or norms that we think we might have. And it doesn't matter if you're wrong about the facts. It doesn't matter if, objectively speaking, you got it wrong. And it doesn't matter if your action has bad epistemic consequences down the line. What matters is that you did the best you could, given what was available to you. You did the best you could in the sense that you respected the epistemic duties and norms that were relevant at the time. So what might these duties be? We don't have any for imagination yet. And that's kind of the point of the rest of this talk, to try to say what they might be. Some examples of duties that you might think are on the action, if you like, of coming to form a belief might be that you should only form a belief, that P, if you have sufficient evidence, that P, or if and only if. Or you should ensure the accuracy of existing doxastic attitudes. In other words, kind of make sure that your beliefs are accurate, something like that. Now, Sheridan and Bechtel have a kind of deontic epistemology in their chapter that I referenced before. They don't call it this. I don't think they think of it this way, but I think it could be thought of this way. So they're talking about a case where biologists researching circadian rhythms come up with some models, and the models are wrong. They're not the right models. Eventually they get to the right models, but at first they have a bunch of models that are mistaken. They're inaccurate with respect to the target system. But they still want to say that they have attained some kind of imaginative success just by making these models. So in the quote, they say constructing the diagrams, but for them, the diagrams and the models are kind of the same thing. And so the success consists in integrating known data, fitting these into a generalized hypothesis, generating a new model of how such a mechanism could work. In other words, they've done a good job by using their imagination to fit together the existing data into a kind of plausible hypothesis, even if the hypothesis is false. So they put it in the language of how possibly it counts. So even if it doesn't tell you how the mechanism or how the system actually works, it tells you how it might work. And I want to say that it's successful in the sense that it respects our it respects our existing doxastic attitudes. It produces a new sketch which coheres with background theory and empirical data and so on. And it's successful regardless of whether it's true. So to summarize, when asked to discuss current uses of imagination, I think scientists, and I found this in other labs too, they are happy to adopt a kind of deontic meta-epistemology. They're happy to talk this way. They seem to imagine in a way that respects, they think that it's good to imagine in a way to respect our duties to background knowledge and empirical data. Of course, that's a pretty low bar. What exactly does it mean? What exactly is the specific epistemic duty that we have for scientific imaginings? Is it just that we should respect our existing background data? I don't think that's good enough. I don't think it's specific enough. So kind of the point of the talk is to say, what more can we say about the duty that we might have, an internalist duty for scientific imagination? So Amy Kine says, everybody agrees imagination is not constrained necessarily by how the world is. So for imagination to be epistemically useful, we have to set and follow constraints that make imagination constrained to represent the world as it actually is. So maybe the duty that we have on imagination is to set and follow constraints. But I don't think it's that easy, because it's also important to break constraints. Imagination is extremely valuable in helping us get out of conceptual systems, breaking with existing constraints. So let's go back to a case study quickly and look at some constraints that you find in space science. So for example, you should constrain your imagination to think of possible solutions to problems that give you solutions which funders will like. Because if the funders don't like you, if NASA or ESA or JAXA doesn't like your idea, then you're not going to get the funding, so don't even bother. You should constrain your imagination according to what the PI wants. If you're the PI, then okay, that doesn't apply to you, but most of the time, statistically speaking, you're not the PI. And depending on where you stand in the hierarchy of power, you have more or less flexibility here. But generally speaking, you should imagine stuff that's going to give you the solution that the PI wants. There's what you might think of as paradigm-based constraints. So you want to constrain yourself to use the methods that are normally used to solve whatever problems you're supposed to be tackling, given the kind of general norms that hold in the specific subdiscipline you're in. You're going to be constrained by the mechanical system. So the instrument you're working on probably almost certainly wasn't designed by you. All the instruments are inherited from previous problems. So the one that we're talking about, PROSPA, was inherited from a previous kind of extraterrestrial probe lab that was used on the Rosetta lander to land on a comet. So they adopted most of their stuff from that. You don't really have the choice to completely redesign the mechanical system because you know that the previous one worked, so you kind of have to keep most of that. So you're constrained to imagine a solution where you don't really change the mechanical system. You're also constrained to imagine solutions that you can actually perform given the tools you have in the lab. You have time constraints, so don't imagine a solution that's going to take you 5 years to build if you've got to do it in a month. And also, of course, probably most importantly, you have background theoretical knowledge. At least philosophers will say that's the most important kind of constraint. But note, occasionally, it might be important to break any one of these constraints. People who are really excited about Venus now because they found certain evidence that might support the idea that there could be life on Venus, they've been saying we should go to Venus this whole time, and they've been coming up with plans about how we could do it. And funders did not care about Venus up until right now, but it's kind of a good thing that these people were still interested despite the funders not being interested. You can obviously sometimes go against what the PI wants. You can ignore what the PI wants sometimes, and sometimes that's actually for the best. Sometimes you want to use methods that nobody else has used before. You have to use a new method that didn't exist before. Also, sometimes you have to reinvent the mechanical system. And that's exactly what happened in the case that I talked about here. They had to completely redesign it so that they could put the whole thing into an oven. Other times you aren't constrained by what's in the lab. You have to invent a new tool. For example, you need a special kind of tool that doesn't exist in your lab or exist in any lab, and you have to make it from scratch. And that's just sometimes what you have to do. And imagining that kind of solution isn't always a bad thing to do. Sometimes you want to imagine a solution that takes a little bit longer than you actually have, because that might be the best solution that there is, and so on. So sometimes you're supposed to satisfy constraints. Sometimes you're supposed to break constraints. So how do you know which one you're supposed to do? Well, I'll take a cue from a bit of psychological research on aha moments, so-called aha moments. These are moments where you know a good idea, or you have an idea that you feel like is good. So there's an emotional reaction, there's a kind of hormone dump that they say is a sign of suddenly experienced coherence between what you want and what your representation offers as a possibility. And so a kind of silly example would be you wander into the kitchen in the middle of the night, maybe not the middle of the night, you're feeling a bit sad, you see flour in the cupboard, you imagine a few things you could do with flour, you realize you could make a chocolate cake, and then suddenly you have a rush of excitement. That's what I wanted. You didn't even know you wanted chocolate cake. But this sudden coherence between what you actually wanted and what you can see yourself doing makes you really excited. So the emotion isn't what justifies the idea. The emotion is a kind of signal that says, pay attention to this idea. This idea is the one that we want to focus on. I think it's the strength of the coherence or something like that that justifies our decision that the idea is a good one. The new idea satisfies constraints and breaks constraints in a kind of good way. We may not have even been aware that we wanted to break those constraints and satisfy some other constraints, but the new idea somehow satisfies us. Because we realize that it deals with constraints in general in the right way. But what's the right way? I think the right way balances the breaking and following of constraints. I think ideally scientists would want to satisfy all the constraints because that's literally the easiest thing you could do. But if you could do that, then you would have done that and the usual methods would have worked. If you could satisfy all the constraints using the usual methods, then you would have, but you couldn't. That's what a problem is. So these problems that are recalcitrant, we say, these problems that don't go away just by using the usual methods, those are a sign that some constraint has to be broken. But still, you probably want to break as few constraints as possible. So this becomes something like a kind of complex minimization problem. You can break any constraint you want, and you can break it by a lot, but you don't want to break it by a lot. And if you can avoid breaking constraints, you should. And it's not always easy to see which idea gives you the best balance of breaking constraints and satisfying constraints. And I think this kind of uncertainty gets us closer to what we want, something like a norm for internal Deontic kind of epistemology of imagination. And it also kind of explains how the scientists talk. So if a scientist says, hey, what about this? Either everybody's going to be like, yes, that's it, but probably that's not what's going to happen. Most of the time what happens is everybody goes quiet for a second, unless the idea is obviously bad, then also somebody just says no. But most people will go quiet. And then you want to ask yourself, what are they doing when they're going quiet? I think they realize that they don't have the emotional reaction that they would have had if it was the right idea, if it did have the right balance of breaking and satisfying constraints. So they're trying to see if the constraints it satisfies and the constraints it breaks are the sort of right mix. Maybe there's a better mix. Maybe something like this is on the right track. Maybe we're almost there, but maybe not quite there. Is there some other idea that's similar that breaks less constraints or different constraints? So a good imagining is going to be one that respects the duty of breaking the minimal amount of constraints required to solve a particular problem. And that typically means it's going to allow us to do whatever it is that we want to do with the machine as easily as possible. I think this can be extended to other places in science other than space science. So you might say a good imagining in physics is one that solves a physics problem and breaks minimal constraints. Now, you might have the externalist intuition. You could say, yeah, okay, but what about the kind of reality of the situation? It seems like a good idea if it has this kind of nice balance of constraint breaking and constraint satisfying. But what about real solutions? Is it a real solution or not? And I think that's fair. I think we can bring in these sorts of considerations. Does it actually work out? I think, therefore, this kind of bottom paragraph, an idea can be good in the sense that it seems like it'll solve a problem. It's genuinely good in that sense, in the sense that it has the right balance of breaking and satisfying constraints. But you can add value to the idea if it actually does solve the problem in real life. That is, if it has the desired consequences. So I've argued before, and I think you might think that scientists are really kind of consequentialists, kind of maybe in some sense in the end, what they want is something that allows them to make progress. They're sort of instrumentalists. But I still think there is a real sense in which they're internalists, at least until they know the consequences. And even when they know the consequences, they can say, okay, that didn't work out the best, but it was still a good idea at the time. And I think the notion of minimal constraint breaking as a duty for all problem-solving acts of scientific imagination is a new idea. It's new to the literature on the epistemology of imagination. I think it could make both people like me who like breaking constraints and people like Amy Kine who like satisfying constraints happy. So let's talk very briefly about some final consequences and then we'll wrap up. Yeah, sorry, Karen, go ahead.
So you're gonna wrap up very soon. Maybe I can ask my question at the very end.
Yeah, just another minute or two.
Okay, good.
Thanks. So I think actually I've been going on for a pretty long time, so maybe I'll skip this one. Basically just that there's also a distinction between subjective and objective justification, and it kind of works nicely with this one too. But I think there's one kind of interesting negative consequence of this. I think it's good that this brings it out, but it seems like the norm to break the minimal number of constraints comes from the fact that we train scientists to be efficient, to be basically conservative, to stay in the paradigm, to do normal science. I don't think the norm has to be keep it minimal, but it is keep it minimal. Following this norm, I think, ensures that science stays conservative. And there's a whole bunch of problems that come with the conservativeness of science. And somebody who's conservative or a fan of conservative science might say, well, no, I mean, it's good that science is conservative like this. It's more efficient this way. And somebody else might reply, well, yeah, it's efficient at producing masses of tiny, boring, useless results. This is one of the criticisms of conservative science. So there's kind of an interesting question here about whether this, I mean, even if I'm right that this is the norm governing certain uses of scientific imagination, maybe we might want to argue that there should be a better norm, maybe a bit more flexible norm, that it doesn't have to be minimal constraint breaking. This was for my students in the philosophy of science class, but we can sort of skip over this basically just about what Kuhn would say. In sum, space science could be, I think, an interesting case study for philosophers of science. I think if you look at space science, imagination is used there like in other places to solve problems, and they only use it when everything else fails. I think there's a sense in which imagination has to be evaluated internalistically and not externalistically. That is, at least until you know how well the idea actually works out. Internalistically, and imagining is good insofar as it respects the norm of producing ideas that would potentially solve the problem if it was correct, and which happily balances constraint breaking and constraint satisfying. And yeah, basically, I just think it's kind of rare to see people bring together these resources from mainstream epistemology and to bring them to philosophy of science. I think that's kind of a neat thing to try to do for those of us who are interested in how science succeeds or makes progress or generates new knowledge or understanding. In science, we should be cooperating with people in epistemology who wonder about those things as well. And I think it's kind of neat that, at least in the case of scientific imagination, it seems that we found the opposite of what we were thinking of as the standard view for a while, which is that science is paradigmatically externalist. It seems like here's a case at least where it's definitely seems not to be. Anyways, I think all of that's exciting, and I'm excited to hear what everybody else thinks. Thanks very much.
Thank you, Mike. Shall we first ask students to students have any questions? If you have any questions, please raise your hand. Minzhong?
Yeah, so my question is regarding the internalist, those norms for scientific imagination. I'm wondering how exactly is the standard of minimal in these kind of norms, and how does scientists know that this kind of balance is reached just by their kind of internal states, or it has something to do with the reality? For example, the idea that they have is could satisfy the constraints and break the minimal ones, and that really works. The way that work means is kind of external. So my question is that the first one is, what does minimal exactly means, and how do scientists know that it reached the minimal state? And the second one is that And in order to reach that state, it seems to have to rely on the external state. I mean, about which the idea really work or not. So does this still count as an internalist account? Yeah, that's my two questions. Thanks.
Thanks. Those are exactly the two questions that I'm most worried about. So thanks for getting them right up front. So I'll start maybe with the second question first. So there's at least two ways I think it might go, and that's because you see the same thing in mainstream epistemology and in ethics, and I don't actually know which one I like better. I think I know. Anyways, the two ways are that a new idea that somebody comes up with via imagination is a little bit good when it has the right balance of satisfying and breaking constraints, and then better when it actually works out. So it's internalist and externalist at exactly the same time. And some of the goodness is explained by internalism and some of the goodness is explained by externalism, but you need both for the full picture of how justified it is or how good it is, how much epistemic value it has. A different way to think about this is that ideas just have two separate ways of being good. So an idea can be good in the internalist sense and bad in the externalist sense, completely good in the internalist sense and completely bad in the externalist sense, and vice versa, completely good externally, but completely bad internally. And so these are just different ways of evaluating a single use of imagination or a single idea. And I think I'm more tempted by the second one. So I think maybe that's the way I would say that they interact. And that's because if you talk to scientists about it, sometimes you'll say, can you give me an example of an imagination that was really bad? And they'll say things like, I had this idea and I thought it was a good idea at the time. And actually, you know what? It was a good idea. It's still a good idea, but it didn't work out. It didn't turn out to be true. It didn't turn out to, give me a project that got funding and that, made me famous. I couldn't publish anything about it. Consequentially speaking, it was not a good idea at all. It wasted, let's say a year of my life or something. Terrible consequences. But internalistically speaking, it was a good idea. It was a good idea and still is a good idea. So I think because the scientists do talk that way, I think I'm tempted toward the second, where I would say these are just different ways of evaluating the same thing. Then you want to say, but come on, Mike, isn't there some overall thing we can say? What do we do about this? And I think, I don't know what to say about that. I think I would just say there's just these two different ways. And I think scientists often privilege the externalist way, kind of in the full light of reason, looking back on all of the things that happened, but they can't privilege the consequentialist way when they're looking to the future or to the present, when they have a problem that they're trying to solve right now. They don't know the consequences. They have to be internalists because they don't know the consequences. So I think which one matters the most shifts depending on the context. So I don't know if that's fully satisfying, but that's kind of what I think about that. The other question about what's the kind of sense of minimal, that's very, very difficult. And I'm not exactly sure. So I think my answer to this question is just going to be, I'm going to have to do a lot more. I'm just going to have to do more research and see what they say first, because I want whatever I say to be consistent with actual scientific practice. My guess would be that some constraints matter more than others. And in a field like space science, you don't want to break the constraint to stick with your background theory. You don't want to say physics is wrong. That's a constraint that you could break. You could break that one, but definitely try not to break that one. So some constraints kind of are more heavy or more important than other ones. So if you have to break the time constraint, you're supposed to get it done in a month, but you have to take 2 months, it's kind of not a big deal. If you have to rebuild part of the instrument, okay, that's also not that big of a deal. If you have to, refute modern chemistry or something, that's a big deal. Don't do that. So I think the constraint you pick is important. And then how much you break the constraint by is also important. You want to break it kind of the least amount that you have to break it. So that's probably also going to be contextually evaluated. So I have to rebuild the machine somewhat. Do I have to rebuild the entire machine from scratch? Or do I just have to rebuild I have to rethink that part, or I have to rethink part of the structure, or all of the structure, or all of the structure and the material? So there's different ways that minimality can be done there. That said, I think you could have a situation where, let's say you only have two constraints and both of them are fine. You can break either one of them. You could break constraint A by 0.5, and you don't break constraint B, or you could break constraint B by 0.5 and you don't break constraint A. These are equal in terms of the weight and so on. So there could be situations like that. And I don't know what would happen in those sorts of situations. Maybe if it was truly equal, the scientists would just say, yeah, either one's fine. So that's kind of all I have to say, I think, so far about this. But I'm definitely going to think more about it. And thanks for bringing it up. I think that's a great question.
Okay, Yunying.
I think some of them is answered by the discussion, but I'm interested about the research methods about ethnography. Is there any difficulties when you are deal with problems with scientists that which paradigm did you follow? As a philosopher, is there any difficulties you confronted when discussed with scientists? Yes.
How much time do you have? There are lots and lots of problems. Yeah, it's very difficult. So, and it's very difficult sometimes in surprising ways. So at first I thought they weren't going to want to talk about imagination. I thought they were going to say, no, we don't use that fluffy stuff. We just do the math and we do the experiments. But it's in many cases the opposite, especially if you're talking to an old white man. The old white man will not stop talking about his imagination. He just wants to talk about how powerful his imagination is, how his imagination is the thing he has to thank for all of his success and achievements and so on. Whereas if you talk to somebody who's younger, somebody who's not well established, somebody who is in a kind of more vulnerable position, they'll say stuff like, oh, I don't use imagination, I just do the math. And then it's kind of sad because you're trying to make up for the fact that you're in a vulnerable position. You're trying to kind of make yourself look like the best scientist that you think you're supposed to look like, given what they told you in undergrad and grad school. So there's like really interesting social dynamics that I wasn't expecting to encounter when I started doing this stuff. And what I want to know is like the truth about how imagination works, but I can't look into their brains or into their minds. So I have to kind of unravel the social dynamics first and then kind of look at what's left underneath. So that's some of it. Obviously, there's also a big difference between what scientists say and what scientists do. So sometimes they'll say things that their professors told them. Here's how imagination works in science. Imagination plays the role of generating a hypothesis to solve some significant problem or whatever. But then in reality, when you look at what they actually do, they don't use their imagination on like big problems. They're like, science needs imagination to some grand thing, but in reality, they only use it to solve the tiniest problems. They never use imagination to solve big problems. That makes no sense, it turns out. I wasn't expecting that sort of difference between I was expecting some difference between what they say and what they do, but I wasn't expecting necessarily that particular difference. So there's lots of difficulties, but I find them exciting and it's fun. It takes a long time, but it's worth it in the end, I think. Yeah, but I'm happy to talk more. If you're interested in using these sorts of methods, we'd also be happy to talk about how to use them and what sort of coding methodology, for example, to use, grounded theory or analytic induction or these sorts of different approaches. Yeah, thanks.
Thank you.
Tati.
Okay, hi, Mike.
Hey.
Well, I have always been thinking that philosophy really needs to take science into consideration rather than just set it aside. And as I learned more about philosophy, at least 6 years, and I got more frustrated. And anyway, I was kind of expecting that your talk is going to say something like, what are you going to change about the space science with your philosophy work? And well, anyway, so maybe I just cut in straight to the point. So what is the real implication of this thinking of imagination in general for science? I mean that it doesn't seem like you are asking the scientists to imagine in a way that you have proposed, right? In order to gain those epistemic value, which they don't care. or okay, let me put it this way. Maybe we can imagine two scenarios where scenario A is where scientists do the space things without any philosophical thinking. And scenario B is where the same group of scientists who have been fully aware of your proposal think about how to carefully use imagination, something like that, end up doing the same space things as well. And are these two group of scientists going to do things differently? I doubt it, and I'm not quite sure what is your opinion of this.
Thanks. Yeah, that's a great question. I really like that question. I think
Thank you.
I like it. It's practical. It gets to the point. It's a very good question. So, I do want what I find to have practical results for scientists. I want it to help them. And one thing that I found when interviewing scientists is that they're, as scientists, they're obsessed with efficiency and making every one of their methods the most efficient. I don't know how much time you spent in like science labs or if at all, but they talk about meetings scientifically. They like experiment with different lengths of meetings. They like every single aspect, a PowerPoint presentation, everything they treat scientifically. They want to know how everything would be best organized as a method to solve their problems. And when they talk about imagination, when I ask them about imagination, they suddenly realize that they have no method for imagining. They realize imagination is extremely important, that they need it to solve all of the kind of interesting problems, but they don't know how their own imaginations work, and they don't really know why they think certain things are good or bad, and that bothers them. They don't like it. So one thing I can offer is a kind of expanded understanding of what they're actually doing back to them. And so when I have done this, when I tell the scientists, they ask me all the time, they'll be like, Mike, so what have you found out about us? What are we doing? And I tell them, and they're like, that's so cool. One of them wanted to put it on their website to say, also, it turns out how we imagine. And so, for example, the social dynamics they had no idea about, and that's a huge problem that they want to solve. So how can we teach imagination in a way that allows younger people to feel more free in imagining, despite the fact that when you train somebody, you have to teach them all of the rules and all of the techniques. So you kind of have to teach them not to imagine for a while, learn all the techniques, and then they can imagine later on. So somehow you have to kind of balance these different constraints in teaching. So one thing I think that's going to happen is they're going to learn how to teach imagination differently to students, which isn't necessarily at the cutting edge of science, but it is really important for eventually changing the cutting edge of science and the way that science works. But specifically with respect to this talk, I think one thing that could be done is to start a discussion with scientists about how minimal they really want to be when it comes to breaking constraints when they face a problem situation. So do they really want to be as minimal as possible? Or would they allow that sometimes you can be a little bit less minimal? You could break constraints a little bit more and see what happens. How kind of open-minded and imaginative do they want to be? Do they really want to use the minimum amount of kind of imagination as possible? Or would they want more? And if not, why not? And so these are philosophical conversations that I find scientists are interested in having, and I think could have really interesting repercussions. For example, they might say, no, I don't think we should always be minimal, but I don't think we should always be maximal. I don't think we should always kind of be at any given level. Probably the context of the problem situation changes how much imagination we want to use and how many constraints we want to break. And even just a realization like that, I think, could be really helpful for scientists in giving them some structure for how they imagine their way through a problem. So I agree with you. I'm also worried about whether or not this has very many practical implications, but I think there is some hope that it does have some. Otherwise, I wouldn't be doing it. So thanks, Shao-Chi.
Yes, thanks. And I, after hearing your response, I think we are still having hope.
Yes. Thanks.
You're welcome. Yeah, Sonko, thank you too.
Thanks.
Any other questions from students? Ian, do you want to add? Okay. You're giving lots of people some good memories and good time. Yeah. So if there's no more questions from students, let's open up for everyone. Can I first ask a question? Okay, let me first ask a question. So you were talking about the ethical issues of space science, and also about how many dogs have been in space compared to the number of women. And so it kind of reminds me of like, and you know what we are working on with bias, and how we can reduce bias. And so I'm thinking about as like this the idea of situated knowledge from Haraway, and how one is constrained by his or her historical or geographical or other like cultural circumstance. And I mean, like, when it comes to that, it seems that this kind of constraint, I'm wondering if this kind of constraint is the same kind as you were talking about. And if it is, it may be difficult to follow what you were talking about, like balancing or minimizing breaking constraints.
That's a great question. Thanks. So there's Fiora Salas, I think, talks about so Amy kind of does too, but I think Fiora kind of goes a little bit further, talking about architectural constraints on imagination. So constraints like that, I don't think you can, I mean, some of them you can't change. You kind of have no choice but to abide by some of those constraints. I was thinking more about the constraints where you do have choices, but there's a really interesting middle ground where there are constraints that you kind of can change, but you kind of can't. And so thinking about unconscious imagination or kind of subpersonal imagination seems like a really good example of this. So, a physicist who's been working in one field of physics for a very long time will have very, very strong kind of unconscious imaginings when they come to a certain kind of problem situation, which might usually or always be very helpful. They were trained to help with that situation. But then sometimes they might have to change the physics, and they don't have the ability to kind of break that kind of constraint because it's so deeply ingrained in them. So their life history, in some sense, kind of determines what sorts of things that they're even able to imagine. But that doesn't mean that they can't change them. They can change them. It's just going to take a long time. They have to reprogram their unconscious imagination. And I think probably a lot of cultural biases are exactly like that. So I don't know if I agree with kind of implicit bias training. I'm not sure if that's necessarily the way to go. There's definitely some problems with that. But there are things that you can do, I think, that do change. I mean, you can get rid of biases. It is possible. People do overcome biases, and there are ways to do it. Maybe exposure is one way people talk a lot about to the things that you're biased against, and so on. So I think that's a super interesting case where it kind of makes it look like science is kind of irrational. It sort of depends on these things that you don't have complete control over, but of course you do have some control over them, which is really interesting. And the kind of optimistic upshot of all this isn't that we're stuck inside of our brain cages with specific things. The nice thing is that we can use diversity to bring in other people who have different sets of unconscious imaginings and biases and so on. That can help, of course, just like you say in the paper about situated knowledge knowers and AI and programming XAI algorithms. So I think something similar can happen with imagination in space science or any other kind of science. That's great. Thanks.
Wei Zhen.
Hi, thank you for the talk. And I wanted to ask a question about the way imagination is defined. So at the beginning of your talk, you made the distinction between imagination and abstract thought. And I just wanted to ask how important that distinction is for your project. So you mentioned that two of the defining features of imaginative representations are that they are imagistic and they're fictive. And I just want to know whether these have anything to do with the problem-solving aspect of imagination. So take the feature of being fictive. It seems that if our goal is to solve the problem, then it'll be even better if it's not fictive. If it's actual in some sense, then it will just work even better. And when it comes to the feature of being imagistic, it seems that to solve the problems, we don't have to have imagistic thoughts. I mean, abstract thoughts would do as well. So I just want you to ask, what do you think about this, and why did you define imagination in that way? Thanks.
No, yeah, thanks. That's really helpful. So part of it is because I want to avoid problems in the literature on imagination. So there's a huge discussion about sensory versus propositional imagination, and there's lots and lots of debate over which one is the kind of real one that we have to focus on. So some people argue that imagistic imagination, we don't ever have to talk about it when we do epistemology of science. It's kind of, in some sense, totally irrelevant, that everything reduces to propositions and manipulations of propositions. And so part of the reason why I want to focus on imagistic imagination is because I kind of want to defend the usefulness of that kind of imagination. Sometimes I think it does play really important roles. All the scientists that I talk to in this case talk about imagination as synonymous with kind of like mental imagery. I think that's also sort of interesting and significant, but I completely agree with you that if I hadn't made that distinction, if I was just talking in general about imagination, it would be totally fine. I think the point would still hold, whether it was propositional or imagistic. Yeah, I'm basically just defending kind of the imagistic imagination a little bit there. Fictive, this is a really interesting thing here. So there's, you want to be able to say imagination is different from other kinds of thinking, otherwise it's not interesting, right? So you want to say that thought is different from imagination, or reason maybe is different from imagination. And what's the difference? Well, there has to be some sort of difference. So you might say that the difference can be extremely small. So if I imagine everything I'm seeing right now, but I imagine that, I don't know, there's a bug on the back of this computer laptop that I can't see, then that suddenly counts as an imagining and not a perception. All of this stuff looks like perception, but you add one element that's kind of not present or not presumed to be actual, then it suddenly becomes an imagining. And some people would say, no, that's not enough. That's not fictive enough. It has to be kind of more fictive. Okay, just pretend that there's a speck of dust somewhere in the next room that might not actually be there, and then suddenly all of my perception becomes imagining. So there's a really interesting discussion about how fictive something has to be in order for it to become an imagining. People who think that, so phenomenologists, for example, I can see the front of your face, but I can't see the back of your head, but I assume that there is a back of your head. So in some sense, I'm imagining that you are a three-dimensional person instead of a two-dimensional person. So they would say imagination is, is completely through, it penetrates all of my perception. Some people say that's way too much. Imagination shouldn't be that broad. It shouldn't be everywhere like that. It should only be kind of purposeful things that you do in your mind that are different from just manipulating representations. So I included a fictive element, and I think Sheridos and Bechtel did too, for that reason, that they want to be able to say this is not just manipulating representations in a way that you think is perfectly accurate about reality, because that's just reasoning. There's something that makes it imaginative. But I'm willing to be flexible on how fictive we think it should be. Yeah, thanks.
Thank you.
Karen.
Oh, hello.
Hi.
My question is related to Guizhen. So I want to press on this fictive part of your account. So let me start with this question. So in your account, is there any difference between counterfactual reasoning and thinking versus imagination?
So if it's image, I mean, so there's of course a big problem about how Xiaoqi wants to see Daisy. There's a big problem about how big or small we define acts of imagining. So the mental state of imagination is pretty easy to define, but the act of imagination is pretty hard. So do you include the whole thing, or just sort of part of it as the part that's imagining, or do you include the whole act of reasoning as an imagining? So with a counterfactual, you might say that just seeing the scenario in the antecedent, that's the imagination bit, but the inference is not imagination. That's just logic. Or you might think, no, the entire thing, the antecedent and the consequent and the connection, that's all kind of done in imagination. I'm not sure actually what to say about this. I don't actually know. I would say that you can evaluate a counterfactual using the imagination by exploring the antecedent to see if the consequent is somehow involved with what you imagine in the antecedent. But if you wanted to say that a counterfactual was kind of like a purely logical construct that was just like a deductive modal logic thing, I would say maybe that's not imagination. So in other words, I don't really know.
Okay, so then let me try this angle about this. She showed up.
There she is.
Fictive.
Exactly what I guessed.
Okay. So since you focus on this balance between constraint, breaking, and I think you say following.
Satisfying. I don't know.
Satisfying?
Yeah, doesn't matter. Yeah.
Okay. So when I first heard this idea, I get this gut reaction. I'm not sure if I can express it clearly now, but I felt like a lot of like for some mental activity science doing on-site, I don't know how to call it, you can call it thinking, whatever, but it's also about constraint, breaking, and satisfying. And so it strikes me that, if that's how you ground your account about, what makes imagination epistemologically good, I kind of worry that is that enough to differentiate imagination as a mental act versus maybe that's a following Guizhen's example, like problem solving. So you can imagine acts versus get asked to work, or get asked to work to solve problem. And that's assumed for the sake of argument, they involve two distinct sets of mental activity or mental acts. And I guess, one way you can respond to me is to say, well, let's go into this more like detail about this minimum balancing between constraint breaking and following, to say, there's these two sets of activity I can show in this specific case within this specific context, that the constraint, this satisfying with this dynamic balance are different. But but then you want to offer some kind of in-principle account of imagination, and then the constraint, notion of constraint, is a very qualitative term. So I even worry about the fact that you say it's a minimum. I mean, constraint probably not countable. Even it's countable, the content of the constraint is so qualitative that it's just like, it seems like a constraint has to be, what counts as a constraint has to be some kind of really, really, analyzable and so clear for you to use this strategy to answer my worry that by analyzing through constraint, I can show you that why imagination and getting asked to work are involving two different sets of activity.
That's great. Thank you so much. Yeah. So one thing I would say is that one of the cutting edge in epistemology of imagination is that if we focus on constraints, all of our problems are solved. Constraints answers all of our questions about the epistemology of imagination. And so I think you agree with me that we need to go more. There has to be more that needs to be said about not only what it means to follow a constraint, but also what it means to break and when we want to do these things. So there has to be way more that we need to say about that if it's on the right track, which maybe it's not, but if it is on the right track, we need to say more. Otherwise, I think we still can use the notion of constraint to differentiate between acts of imagination and other sorts of acts, because I think some acts are going to say, never break the constraints. So if you're reasoning mathematically, if you're performing a deduction or a calculation, don't break the constraints, ever. If you're,
That's why it starts with counterfactual reasoning.
Mm-hmm.
I mean, my understanding of that, yes, it's a lot of part involving deductive reasoning, but the antecedent, it still has that imaginative element for it to be counterfactual reasoning. And in that for that element, I feel, okay, I think that still involves some kind of constraint breaking.
I agree. Yeah, because you're coming up with a representation about how the world might be other than the way you actually think it is. So I agree. Yeah. So I would say that part definitely is imaginative, and that part, I mean, I think probably all the places where you find real constraint breaking, you're going to find some imagination, and that's part of the reason why imagination is so important all throughout science.
So why not just make this you can constraint following is more like a reasoning, problem solving activity, and then constraint breaking just like the distinct feature of imagination. And in some of the work scientists do, they do simultaneously use these two activity at the same time. Why can't you have a hybrid version of it?
Yeah, so I kind of say that in the philosophy of science article, but I'm a little bit too scared. But I sort of agree with you that that's the kind of the thing that makes imagination distinctive. And I share with you the worry that constraint following is just kind of reasoning. It's this sort of nothing special about that. That's just kind of your average regular stuff. Just that all of the people in the epistemology of imagination literature, most of them say that constraint following is what makes an imagining good. To me, it's what makes an imagining less interesting. And so that's what I try to say in that paper. And basically, I agree with you. I'm not a full professor yet. When I become a full professor, then I'll say that. I'll write a book on it. Thanks.
Okay, no more questions. Thank you.
Thanks.
Hi, Mike. Thanks for the wonderful talk. I really like it. My question is a little bit related to Inton's question. I'm wondering about breaking the constraints. So when I was still in a mechanical engineering lab, when I was designing some mechanics, when I really make my project successful is when I really break some constraint. But before I break my constraint, I need to know what is the constraint. What are my constraints? I'm just wondering. I'm just wondering. But if I want to break a constraint, then I need to know at the first place what my constraints are. Then how do we know about our constraints? And in my own experiences, when I trying to know what are the constraints, I use some counterfactual reasoning or maybe even some imagination, in the sense that I need to jump out of the immediate environment and just thinking about, okay, where I'm really right now. Yeah, but I'm just wondering your thought on this. Yeah,
that's super interesting. I actually hadn't thought of that before at all, and I think my intuition is that sometimes you find out what the constraints are after you break them, and maybe your experience is similar. You realize, whoa, what's going on? I've never been here before. How did I get here? Oh, it's because I did this other thing. Oh yeah, and normally you're not supposed to do that. And you kind of realize that there was a constraint, but you didn't realize it before at the time. So I think what happens a lot in science is that scientists expect that to happen. They kind of know that they'll find the constraints when they break them. And it's kind of a lazy way to do your methodology, but it works for the most part. You do kind of end up breaking the constraints that you need to break. And you don't really have to have a complete catalog that's always updated of all the constraints that you should be thinking about. So I think that's more or less fine. But yeah, I think probably something like that happens. I think in some cases you'll have really clever people who do stop and think, and they think like, why are we having this problem? What part of the theory is the problem? And then they specifically vary something that's supposed to be a constraint. So Einstein famously does this when he comes up with special relativity. He says, none of this is working. It's all a mess. And then he says, like, what if I make that constant? What if I make this other thing constant? What if I make this constant? What if I like break the rules in different sorts of ways? And he realizes, oh, if I make the speed of light constant in every single reference frame, no matter what its inertia is or whatever, then the math all works. So he was purposely trying to break constraints just to find out what solution would give them the results you wanted. So I think it can happen consciously and on purpose, but probably most of the time it's kind of by accident and you just find out. I don't know if that makes it a little bit externalist, because you can break constraints without knowing you're breaking constraints, and you can break the right constraints the right amount without necessarily knowing that you are. So maybe that's something I have to think a little bit more about. I still think the evaluation of it is going to be internalist based on what the scientist has access to, but yeah, that's kind of an interesting, somewhat externalist element that I hadn't thought of. Anyways, yeah, super interesting question. Thanks.
Okay, Yiting.
Hi, Mike. I'm Phoebe. And
Oh, hi.
I'm wondering that how much details can ethnography tell us about the role of imagination in science? For example, how imagination interacts with other mental faculties. Thank you.
Thanks. Yeah, so this is of course, a problem. And I think it depends on how you think philosophy should go about doing things like conceptual analysis and conceptual engineering. And if you think like a concept like imagination is one that we should sort of decide a priori what the best meaning is for that concept to have or something, then maybe you don't really care how the scientists think about imagination, or how they talk about imagination, or how it seems to be that they use imagination. You might just say, oh, that's irrelevant. The philosophers know best. We can decide a priori what imagination should mean, what the content of that concept should be. If you're, on the other hand, a kind of ordinary language style philosopher, Wittgensteinian or Davidsonian, who thinks that the meaning of a term is just how people use it, then the only way to figure out what imagination really is and how it interacts with other mental states is to go out and look and to do a kind of empirical investigation. Probably the best way to go is a mix of the two. So we should have some kind of careful normative philosophical inquiry about what kind of concept best serves the purposes that we want the concept of imagination to serve. And on the other hand, pretty much captures how people actually use the term, or is at least informed by or inspired by how people actually use the term. So I think if that's the right way to go, and if you agree with me about that, then we have to have some empirical information about how imagination is used. Then the question would be, what kind of empirical information do we want? Let's suppose we have kind of two main options. One option is to have a survey of every single scientist in the world. And the survey is like, let's say it's on Qualtrics or Google Forms. So there's a Google form that all scientists are now going to fill out. And the Google form will say like, do you think imagination is like this or like that? How often do you use it? How do you think it interacts with these other kinds of imagination? How would you, define it? And all of the scientists fill out the form. And then we have a statistical breakdown of what the scientists say. And that's super interesting. I would love if we could have something like that. That would be so cool. But it kind of, it's also not super informative in some sense, because the scientists are kind of just going to go on what they think imagination means, or what they think we want to know about imagination or something. There's these well-known problems with surveys. So another option is to do qualitative social science on them, and to not just say, what do you think about imagination in your work, but what do you think imagination is? And then when they tell you, you can say, but what about this thing you did last week? That seems like it's a little bit different, and slowly force and pull out of them what they really mean, what they didn't even know they meant. And so that kind of thing we can't do on all the world's scientists. It would take way too long. You would need a ton of graduate students to help you do that kind of work. So you can only do it on small groups of people. And that means that maybe it's hard to generalize what you find to other groups. I think the best would be to have both, to kind of do a kind of social scientific qualitative study, use that to inform a kind of bigger survey, and then use that to inform another social scientific, and then go back and forth. So that's all a super abstract kind of answer to your question. But I think that's at least the reason why I think we should use empirical methods, and why I think social scientific methodology, in particular, like qualitative social science, what I'm doing, is a good thing to do. But you might still have worries that, the scientists won't really be able to tell you what they're doing. And then I'll say, well, we try to drag it out of them. And you might say, that's impossible to do. And then I'll say, well, then so is maybe conceptual analysis of imagination to some extent. We just have to hope that social science methodology does deliver on what it promises to deliver, which is an analysis of the meanings of people's terms and that sort of thing. And as Karen points out, we're having a really nice workshop, and there's a link in the chat specifically about the use of these kinds of methods in philosophy of science, with a bunch of people who are the people who kind of invented the idea of doing that and who perfected it in a couple of different ways. So one day is going to be on qualitative methods, one day is going to be on quantitative methods, and then we're going to have a roundtable where people will share their different experiences of using empirical methods. Thanks for reminding me of that, Karen.
Okay, Minzhong.
So when listening to your talk about the first half of the talk, like there's so many scientific details of the space science, and it was so difficult for me to understand. I'm really surprised that you get to know all of that during your research at the lab. And you also mentioned that you went to different labs and also get to know their different kind of science work. And it just occurred to me that how did you come to know all that kind of scientific knowledge? I mean, I assume there will be one of the difficulties for philosophers to go into the lab and to have to know all those scientific content that they are trying to do. So I'm just wondering, how do you prepare yourself to know all of that?
Yeah, very good question. So I also, just to respond, maybe Xiaoqi was joking, but actually I find that they're not annoyed by philosophy. They really get excited by philosophers, which is also another thing that surprised me. But okay, getting back to Minzhong's question, there's a couple of different ways of thinking about how to orient yourself for social scientific research like this. One is that you should learn as much as you can about the kinds of stuff that the researchers are researching, so that you can understand exactly what they're saying completely. And another school of thought is that you shouldn't do that, because if you are completely immersed in what they're talking about, then when they talk about, different cancer drugs and how exactly they work, I'll be thinking about the cancer drugs and how they work and the mechanisms and all that stuff. But what I really should be doing is taking a step back and saying, what's the kind of social interaction? How are things working? How are they talking? What looks like a breakthrough? Kind of how do people decide whether an idea is good or bad? And sometimes not knowing all the technical details can help keep you at a slight distance away. So I'm not exactly sure which one of those two methods is the best. I try to do a little bit of both. So what I do is, before I go to a lab, I'll try to learn as much as I can reasonably about what the lab is interested in, some of the main technical vocabulary, bits of vocabulary that they have, that they use. And then when I go there, I don't necessarily, I don't ask them, what did you just say? What did you mean? What does that word mean? Can you explain this to me? I tell them, no, just talk to me like I'm a regular scientist. Pretend I know everything. And then when I go through the transcript of the interview afterwards, if they say something that I'm like, what on earth does that mean? Then I'll Google it and I'll figure out what they were talking about. So I try to learn some so that I can understand what they're talking about. I learn more when I need to know more, but I don't try to force myself to learn everything. There are people who think you should. So Harry Collins is a sociologist, basically, who does this kind of thing, and he truly immerses himself 10 years or more in a lab, and he really completely understands. And even then he says, I don't really understand, not like they do. That's one way to do it. And Nancy Nersessian, I think, just spent 15 years in a couple of different labs, and she does the same sort of thing. I'd love to spend 10 or 15 years in a lab. Maybe I can start now in a new lab there. But yeah, I think you can do it without totally immersing yourself, without needing to know everything. I think sometimes it does help not to know. Thanks. Good question too.
Okay. Any the last question? Or okay. Auntie.
Hi, Mike. I'm just curious about also the method you use, the ethnography. The first question may be, would you have you ever been rejected for interviewing in a lab? And if yes, and how did you put that in your research? If you have a plan to choose which lab you want to interview.
Yeah. So that does happen, and people don't usually I think I've probably been rejected a few times where they say, they just don't answer you. You send an email to somebody who you think seems really interesting, and then they just don't answer. I've had other cases. So the mathematician that I was working with, he won a Fields Medal. He's super famous, and he's extremely busy. So I had a little bit of time with him. I spent some time, talking to his students and had a few interviews, but it was just too hard. He was super interesting. I wish I could get more out of him, but things like that, of course, happen, and it's understandable, obviously. And I think that's mostly the case. As long as you pitch it properly, the scientists tend to be very interested in having you around. You don't want to sound like I'm a spy who's going to steal your results for my own research. You say, I'm doing scientific therapy for scientists. I'm a philosopher. I'm going to help you understand what you're doing. By the way, here are a number of famous scientists who I've talked to, and they all loved what I told them about themselves, and you're going to love it too. You're probably the most famous I've ever talked to, but I've been working my way up to you, and now I'm comfortable talking to a super famous diva scientist like you, and I would love to hear what you have to say about imagination. I'm exaggerating, but if you pitch it properly, you'll find that a lot of scientists are really excited and happy to talk with people. And you don't have to say from the beginning, I'm going to spend months and months in your lab. You can say, it'd be interesting to have a chat about what you think about imagination or about how science works. I'd love to know a little bit more. And then at the chat, if it goes well, if there's a kind of nice rapport and back and forth, then you say, I'd be interested in talking to some of your students. Would that be okay? And you kind of weasel your way into their world. At some point, of course, to pass kind of IRB requirements, you do have to get them to sign a form that says, I'm going to be doing this and that. But by that point, probably you've already built up a kind of friendship and so on. So you do get rejected sometimes, but it's not as much as I thought I would. Most of the time, people are happy to talk to you. Yeah, and as Xiaoqi points out, there's all kinds of really exciting directions you can take this kind of research. You can talk to anybody. You can find all kinds of brand new stuff that philosophers of science have not thought about before because they, rely on anecdotes or textbooks or history reports, which you don't have to do.
Okay. Well, I know time is up, but I just a little curious. Would you ever curious about how philosophy of science, how is the rule of imagination play in philosophy of science? Yeah, and is that investable? Because it will, for example, were you curious about what is the role of imagination play in our institute? Is that something that you could study because you are involved, not just observe? Yeah,
I think, I am curious, and I think the kind of research, this kind of ethnographic sociological research, could tell you something. It could tell you something about how imagination works in philosophy of science. I don't think there's been anything anywhere close to that, as far as I know, about that kind of thing. I think it would be super interesting to find out, but I don't think I'm going to do it. I think somebody else should totally do that. Fengqi, if you're interested, I can hook you up with the right textbooks. You can learn the methods. I'll teach them to you myself, and you can do the ethnographic research. I think somebody should do it. I think it'd be really, really cool. I would watch that documentary. I would read that book, but I wouldn't. I don't necessarily think I'd want to do. I mean, all I do is talk to philosophers, so it'd be cool to talk to scientists or somebody instead. I think that's But anyways, fun question.
Okay. Time's up. So let's thank Mike for this fantastic talk. And let me first stop recording. And maybe after I stop recording,